All right, chapter 4, section 5, day 2. We're going to wrap up solving quadratics using the quadratic formula. A couple things just to review. Here is our actual scary looking quadratic formula. I talk about the origins, about where this comes from, what it's pulled from in another video that I've uploaded into your resources on Google Classroom. Kind of like the summary of that is that it's pulled directly from ax squared plus bx plus c. It's just a very complicated way of solving for that x within that equation. So kind of the main thing to understand about the quadratic formula is that it can be applied to any quadratic equation that you were given and asked to solve for, with one pre-step that has to happen before I can apply the quadratic formula. And that's I need to solve that quadratic equation, whatever I'm given, so that it equals 0. Okay, I need to do that before I can apply the quadratic formula. After that, I just need to be able to identify what a, b, and c are, which are the coefficients, a being in front of the x squared, b would be in front of the x, c is the number that does not have a variable attached to it. And I would take those coefficients, plug them directly into this quadratic formula. I just have to be careful about order of operations beyond that, and I can get my results. I can have up to 2 results for quadratics, again, representing the 2 possibilities about where that U shape can cross the x-axis. I could also have a single result, or I could have no solutions. And we're going to talk about those 3 scenarios today. All right, let me scroll down on our notes. Okay, so we're going to talk about this segment here. It's an item called a discriminant. Now, I'm going to care a lot less about you knowing the names of these things. More important is how to use it. So this is actually an element of the quadratic formula. Namely, it's this piece under here that is underneath the radical, b squared minus 4ac. We can actually determine how many solutions there will be in a given quadratic equation simply based off of this discriminant, basically the stuff that's underneath the square root. And the reason why is this. Each of these elements, the negative b and the 2a in the denominator, it doesn't matter if things are positive or negative. They just represent numbers at the end of the things. Really, kind of the determining factor about how many solutions there will be is underneath this radical, because a radical has limitations. And we talked about this a little bit earlier in section 3 when we were solving using square roots. The main limiting factor there being that if I can't take a square root of a negative number, at least not in getting a real solution. We'll talk about the exception to that rule in the next section. But if I can determine the value, because again, b squared minus 4ac even in itself looks a little more complicated, but whatever result is going to end up there, and especially if I know what a, b, and c are, there will be some number underneath the square root. And that's where these 3 possible outcomes, again, are represented. Okay, so these are the same 3 families of outcomes that we've dealt with in the previous sections. And again, it ultimately breaks down to a visualization of this parabola, this quadratic, this U shape on a coordinate grid, and that this U shape can cross potentially the x-axis in multiple ways. Here again, we see this possibility of 2 intersections, which will be a large portion of all possible parabolas out there. The parabola could also only touch at its extreme point, which we call the vertex. And so they can only, it's possible for the parabola to only intersect a single time, also called one solution or one x-intercept. And it is also possible for the parabola to completely miss the x-axis. And so this one here, you see that it is completely above the x-axis. It will never intersect because of that bend, that U shape. Or if it was a sad face, it could be completely beneath the x-axis as well. But we get these 3 possibilities for the number of solutions. Now, the actual values of the solutions in these first 2 guys right here, that's what the whole chapter is about, how to solve for those x values so you get actual number answers, however complicated they may be, that will represent those solutions. This discriminant that we're talking about right here, the b squared minus 4ac, will simply give us the information about how many possible solutions there'll be. So it's a little less information, but it's still worth knowing because it does help us with what the graph would end up looking like. And so again, we have 3 families of outcomes. Here's how those families are determined. If the discriminant, this b squared minus 4ac, the piece that's underneath the radical in the quadratic formula, if whatever number pops out of that is bigger than 0, so any positive number, however complex it may be, right? Whatever value that discriminant is, if it's bigger than 0, if it's positive, there will be 2 solutions. Because if you think about it, if I take the square root of a positive number, one thing we learned is that whether I'm taking the square root of 1 or a decimal, a positive decimal, or something really large, like 144, bigger, whatever it might be. Okay, when I take a square root of that, I get a positive and negative result. That's where this plus or minus comes from right here. Okay, because for instance, again, I'll use the example. If I took the square root of 9, 9 being a positive number, if I took the square root of 9, most of us would think immediately, oh, that's 3. And that's correct, but also negative 3 as a result, because if I were to reverse that, 3 times itself would give me that 9. That's why it's the square root of 9. But a negative 3 times itself, the negatives will cancel and also give me that 9 result. And so any positive number, I get that same outcome. And so that's why there are 2 solutions for any positive number, regardless of how complex it may be. Now, if that discriminant happens to equal 0, there is exactly 1 real solution. So if whatever popped out of b squared minus 4ac equaled 0, well, if I take the square root of 0, there is only 1 possibility there, 0. I could even think in terms of a plus or minus, but when I add or subtract 0, it's essentially doing the same thing. That's why there is exactly 1 real solution there. And then the other family of outcomes has to do with, okay, well, what happens if b squared minus 4ac, this discriminant, what happens if it happens to be negative or less than 0? Well, if it's less than 0 or negative, for right now, that we can't do that. If you were to try doing that on a calculator, taking the square root of a negative number, it would tell you no solution or an error message. The reason why is because there is nothing that I can multiply by itself that will give me a negative result. Even if I were to think in terms of a negative number times itself, the negatives will cancel, thus giving me something that turns positive, not negative. Okay, and so we will learn the exception to that rule. We're going to learn about a new family of numbers in the next section. But for right now, just suffice it to say that if I end up taking the square root of a negative number, if my discriminant, this b squared minus 4ac, is a negative number, I will get no real solutions. Visually, what that would look like is it's going to completely miss the x-axis. Okay, so how do I apply this? In your assignment, you're going to get this kind of family of questions, right? This is a little bit less complicated than the actual quadratic formula, because then you don't have to worry about this negative b plus or minus, or the radical, or the 2a in the denominator. We're only focusing on the discriminant, the piece that's underneath the radical. So it's actually a little bit faster. But you're going to get asked these kinds of questions. Determine the number of real solutions, not what the solutions are, just the number of solutions. In other words, they're asking which of these families is this quadratic, a given quadratic, going to be a part of. Okay, so we're going to be performing these 2 right here. So let's jump to the whiteboard and we'll make these brief. All right, our first example, again, we're just asked to identify the number of solutions, not what they are, but we're given this quadratic to begin with. X squared plus 8x minus 3 equals 0. So actually the very first thing I would check for is, does it equal 0? This one is equal to 0, so I can just stick with what I have here. If anything was over here, I would want to move it to the other side and combine it with its corresponding like term. All right, similar to what we did yesterday, again, I need to be able to identify what A, B, and C are. The coefficients that are in front of each of these terms. A, even though there's technically nothing here, there is still a number there, and that number just happens to be 1. We just don't bother writing it. So that's going to be A. B, just again, make sure that you keep track of this symbol. That's going to be a positive 8, and C is going to be this negative 3. That's my A, B, and C. So what I'm going to be doing here is simply applying that to just the discriminant, the piece that's underneath the radical, being b squared minus 4ac. And it just becomes a substitution game at this point. A lot less complicated from an order of operations standpoint, but let's see what happens. So when I plug in b for b squared, b in this case is that positive 8. And it's going to be squared. Then I'm going to subtract 4 times a times c. Well, a was a positive 1 in this case. It wasn't explicitly written, but that's what's there. And then c is this negative 3. Great. Well, there's a substitution. Now I just have to do the math part, the calculation. Well, 8 squared, that's going to give me 8 times 8, or 64. And then what I typically would do is I take the time to write that minus sign, whether or not this result will be negative or positive. You'll find out that turns negative here. But 4 times 1 is 4. That 4 times negative 3 gives me negative 12. Okay, and now we can see a minus, a negative, which will turn into plus, and 64 plus 12 gives me 76. All right, so what? What we have just solved is the discriminant for this quadratic. And all I'm going to care about is those three families of results to answer this question. So all it's asking for is the number of solutions. Because this value is positive, that means there are going to be 2 real solutions. And I guess I should have boxed this element, not the previous. This will be my actual answer to respond to the question. Technically, the 76 is just the result. And that's how fast it is. Let's do one more. All right. Second example. This is what we'll wrap up section 5 with. We are given the following quadratic. 9x squared plus 1 equals 6x. Very first thing I need to do, I need to make sure 0 is on one side, so there is some movement that needs to happen here. And the way I would do that is simply doing an inverse operation to move this guy back over here, combine it with the corresponding like term. You'll find out there is no just single x over here, so it will stay separated. But because it's a positive 6x, I would subtract 6x from both sides. Again, 6x will not be able to combine with either of these, so it's going to stay separated, but it will read as follows. On the right-hand side will officially be set equal to 0, so we can apply the discriminant or the quadratic formula, depending on what it's asking. 9x squared stayed 9x squared in this case, and I'm going to write it in standard form, so I'm going to put the x next. It couldn't combine with anything, so it stays negative 6x. And then that plus 1 stays plus 1. Great. Well, now I can apply the discriminant. Again, just being able to identify what A, B, and C are. Okay, so A is going to be this positive 9 out in front. B is going to be this negative 6 multiplied by the x after we had moved it. And C is this positive 1 on the back end. Applying b squared minus 4ac, I'm going to get that negative 6 squared minus 4 times a is that positive 9, and c is that positive 1. Great, there's my discriminant. So now I just do the work. Negative 6 squared is negative 6 times negative 6, or positive 36. I always take the time to write that minus sign. Now I do 4 times 9, which is 36. That 36 times 1 also gives me 36. Well, 36 minus 36 is going to give me 0. All right, so what? That's what popped out of the discriminant calculation. And when I look at my 3 possibilities of outcomes, anytime this discriminant, this b squared minus 4ac equals 0, that means I have exactly 1 real solution. So whatever this quadratic may look like on a coordinate grid, it will only touch the x-axis once. And that's how we apply discriminant. All right, I'll stop recording.